So we're in 6.9. So we're doing proofs with coordinates. So all I want to do, we're not adding anything new, we're not really learning anything new. I'm just going to do an example of a proof using coordinates, the type of thing that's the type of proof that you might be asked to do in your homework or on a quiz or a test. So we want to prove that the medians drawn to the congruent sides of an isosceles triangle are congruent. And we're going to have a drawing. We're going to draw our triangle. So let me draw our triangle here. We're going to have a triangle drawn on a set of coordinate axes. And I want to make this axis kind of big so we can see what's going on here. I'll do my triangle in blue. So there's my triangle. And we're saying this is the x-axis, this is the y-axis. And we're going to have the coordinates of the points. So this is going to be point P. And the coordinates of that point are negative 2a, 0. This is going to be point Q. This is point 0, 2b. And point R, our third vertex, is going to be at 2a, comma 0. So we're going to be given that we're given this triangle, PQR. We're also given that these two sides are congruent. QR, segment QR is congruent to segment QP. All right, so the question asks us about the median. It says something about the medians. We need to remember what a median is. So how do we find the median? What's a median of a triangle? Remember? Down the middle, so it goes from a vertex to a side, and where on the other side? The bisect, the middle. So it goes to the middle of the opposite side. Very nice. So our median goes from the vertex of one angle, and we want the median to the congruent side. It's going to go from the vertex of one angle to the midpoint of the opposite side. So there are our medians. So those are the segments we're talking about. And we're going to call M and N those points. So because those are medians, we know that M and N are midpoints. So those are our medians. So we want to prove that MR is congruent to NP. Those segments are congruent. So let's come up with a plan first. To show that these two are congruent, to show that these two segments are congruent, what are we going to need to use? We have two segments. We want to know if they have the same length. So what does that tell us we need to use? distance formula, just like we did on the opener. So our plan, not plane, plan. We're going to use the distance formula to find the length of MR, segment MR, and NP. Well, we need one other piece of information first. We don't know the coordinates of M and N to use our distance formula. We don't know, we need an x1 and an x2 and a y1 and a y2. We don't have those. How can we find those for these points M and N? What did we figure out about point M and point N? They're midpoints. So how can we find these coordinates? We know the coordinates of the ends of these segments. What do we use to find the coordinate of the midpoint? What was one of our three formulas that we talked about on Wednesday? Distance formula, midpoint formula, and slope formula. We have a formula to find the midpoint. So we're going to find the midpoint of QR and QP. The midpoints of those segments are going to give us the coordinates of M and N, and then we can use the distance formula to find the length of MR and NP, and then we can compare their lengths. So that's our plan. So let's find our midpoints first, because we need those points to plug into the distance formula. So midpoint N. So I'm going to label my points here. Let's call this one x1, y1, x2, y2. So we keep our points straight. So I get x1 plus x2, 0 plus 2a divided by 2. That's my x coordinate. And y1 plus y2, 2b plus 0 divided by 2. So n is going to be the point. 0 plus 2a is just 2a. 2a divided by 2 is a. 2b plus 0 is 2b. Divided by 2 is b. So n is the point a, b. Now let's find m. Let's find the midpoint here. So we already called this one x1, y1, so let's call this one this time x2, y2. So we'll plug into our midpoint formula. x1 plus x2, 0 plus negative 2a divided by 2 for my x, and y1 plus y2, 2b plus 0 divided by 2. So m equals 0 plus negative 2a is negative 2a, divided by 2 is negative a, and 2b plus 0 is 2b, divided by 2 is b. So this point is negative a, b. So I check this off my list. Find the midpoint of QR, PR, and QR. So we did that. Now our second part of our plan, use the distance formula to find the lengths. So over here, let's find our lengths. For the second part of our plan. So let's do PN, or NP. We're going to plug into our distance formula now. So let's do Pn. This is x2, y2, so let's call this point x1, y1 this time. Square root of x2 minus x1. Negative 2a minus a squared plus y2 minus y1, 0 minus b. Squared. Well, I can simplify that. That's the square root. Negative 2a minus a is minus 3a squared plus minus b squared. And finally, NP is going to be, I can simplify that. Negative 3 squared is 9. A squared is just a squared. Negative b squared, I always get a positive number when I do a square. So this is going to be 9a squared plus b squared. And I'm just going to leave it like that. So I just squared everything inside the parentheses. So there's one length. Now let's find the length of MR. And I'll label this point x1, y1, since this one is already x2, y2. Square root of x2 minus x1, 2a minus negative a squared, plus y2 minus y1, 0 minus b. So this is going to be the square root of 2a minus negative a is 3a squared, and this is a negative b plus negative b squared. And when I square this, I get that MR is the square root. 3a squared is 9a squared plus b squared. They're exactly the same. So MR is equal to NP, the lengths. So segment MR is congruent to segment NP. And we're done with our proof. So check this off my list. That was the second part of my proof. And that's what we were trying to prove, that MR is congruent. Found the midpoints, use a distance formula to find the lengths, and compare them. So that's one example of the type of proof that you can do using coordinates. All just using the formulas that we talked about on block. Questions on what we did here? So one nice thing about using coordinates is if you know the coordinates of your vertices, you don't have to worry about it's more like algebra. It's more calculating. You're calculating things rather than having to worry about logic and connecting logical arguments together. Here we're just calculating things, calculating lengths, calculating midpoints, calculating slopes. So that makes with doing that sometimes is a little easier than trying to deal with the logic and putting all the logic parts together. So just a different way of looking at these proofs when we have our coordinates. Is everybody good here? All right. So for the next part, I have a question. Just one question. I'm just going to ask it about several different things. So the question is, can we use coordinates to figure this out? And if so, how? So we're not actually going to figure anything out. We just want to look at these things and say, could we use coordinates to figure this question out? So the first one, we want to know, can we figure out if segment AB is parallel to segment CD using coordinates? Is this something coordinates is useful for? What do we think? I have a no. So parallel, can we figure things out about parallel lines with coordinates? So Lydia says yes. We have a no and a yes. Anybody else? What did we do? What did we do in our example on block day with that rectangle that we had graphed? What did we do with the opposite sides? We calculated slopes, right? And we saw if the slopes of the opposite side were the same. If the slopes are the same, that tells us that the segments are parallel. So we can figure out about parallel segments using slope. So yes, use the slope formula. So if we have coordinates, if we have these segments, and we know the coordinates, we can use the slope to decide if they're parallel. Use slope, if they're the same, they're going to be parallel. How about, so the next question is segment AB bisects segment CD. Could we use coordinates to figure this out? Lace says yes. So first off, what does bisect mean? Cut in half. So cut in half tells us that we might be using what? Midpoint formula. So we could say yes, use midpoint. What else? Would we need another piece of information here? This question is a little bit vague. Would we need another piece of information here to decide if these things were, the segment bisected the other segment? What if my segments look like this? Those are my two segments. Could we figure out if one of those bisects the other one? What do we need to happen for the segments in order to decide if they bisect? They need to intersect at least, right? They need to cross each other somewhere. So first thing we'd have to know is that they intersect. If they don't intersect, then they couldn't bisect. No, one couldn't bisect the other. So we do need a little bit more information. Well, we could use a midpoint formula once we found that out. Angle A, we want to know if we can use coordinates to decide if angle A is congruent to angle B. Can we use coordinates to figure that out? What do we think? Probably. Not as sure about that one. So let's remember our three main formulas when we're using coordinates. Distance formula, midpoint formula, slope formula. Do any of those tell us anything about angles? Not really, right? In general, coordinates don't tell us about angles. So I'm going to say, for now, I'm going to say no. Coordinates don't tell us about angles. Eventually, you'll learn something that has to do with coordinates and angles. If you go further, if you take pre-calculus, we talk about coordinates and how to figure out angles with coordinates. But for now, what we're doing, we can't. Is there a special case where we could figure out something about angles? Something that has to do with slope. Our rectangle example from block day. What did we figure out about the two consecutive sides? The angles were 90 degrees. We figured that out by seeing if the slopes were negative reciprocals. So if somehow this problem had something to do with 90-degree angles, we might be able to use slopes to figure that part out. But in general, coordinates don't tell us about angles. How about AB plus BC equals AC? So first off, what is AB? What is that telling us? What is that quantity? It's a segment. What does it have to do with a segment? Without the segment, without the bar on top, what are we talking about? What part of the segment? The side, or so let's go back here to what we did in our proof. I said NP without a bar over the top was this. The NP is a, what is this telling us about the length, about the segment? Here's the hint. The length. We're talking about lengths. So this is the length of a segment. This is the length of a segment. This is the length of a segment. Can we figure out about lengths of segments with coordinate geometry? Yes, using what? Distance one. How about ABCD, quadrilateral ABCD is a rhombus. Can we figure that out using coordinates? If we started, any of us that started the quadrilateral investigation on block day, isn't that what the quadrilateral investigation is all about? Figuring out what kind of shape we have. So that so we're going to say yes on this one. So what would we need to do to figure out that a quadrilateral is a rhombus? What do we have to figure out about the sides? They have to be congruent, all congruent. So they have to figure out the same length. The sides are the same length, so we're going to use the distance formula. And what else about the sides of a rhombus? What other kind of shape is a rhombus? What's the bigger category that the rhombus is in? Parallelogram. So we have to figure out that the sides are the same length using the distance formula, and that the opposite sides are parallel using slope. So distance formula and slope formula. So that's how we could figure out if the shape of the rhombus. And that's really that the quadrilateral investigation is that kind of thing. Last one. Measure of angle A plus a measure of angle B is 180 degrees. Could we figure that out using coordinates? Rand thinks yes. How would we figure out if this was a 180 degree angle? Negative reciprocals would mean perpendicular. So we could, if we had a special case. What kind of segments? What would we be talking about if we're talking about a 180 degree angle? A straight line. So if this had something to do with a straight line, if somehow we could figure out our angles were on a straight line, then we could figure out if it was 180 degrees. But like we said up here, in general, coordinates really don't tell us anything about angles. So I'm going to say no. Mostly coordinates don't tell us about angles. Again, eventually you'll learn something where we can figure out about angles with coordinates. But for now, with the distance formula, slope formula, midpoint formula, we really can't figure things out about angles. So your homework for the weekends that I'll give you in just a second is there's one proof like we did in the example here, and then there's some questions like these. Could we use coordinate geometry to figure things like this out? So that's what our homework is. Okay, so let me write it up here. Page 416. And there we go.